This question comes from Max, who asks, what if we could ride comets like spaceships? At first, it sounds like science fiction, a cosmic roller coaster through the solar system. But let's break down what this would actually mean for humans, physics, and our solar neighborhood. Comets are small, icy bodies that orbit the sun in highly elliptical paths. Some come from the Kuiper belt just beyond Neptune, while others originate in the distant Oort cloud. They travel at incredible speeds, often tens of kilometers per second. Riding one would be less like driving a car and more like strapping yourself to a natural, speeding projectile through space. One major challenge is gravity. Comets are tiny compared to planets, usually just a few kilometers across. Their gravity is so weak that you could jump off into space with minimal effort.
In fact, even your body's own movements could push you away from the surface. So we'd need some way to anchor ourselves securely. Magnetic boots, harpoons, or tethering lines. Otherwise, the first bump could send you drifting into the void.
Next, there's the problem of speed and trajectory. Comets are moving extremely fast along precise orbital paths. If you could somehow board one, you'd inherit its momentum instantly.
This means you could travel vast distances without fuel, riding along like a passenger on a cosmic bullet train. But any attempt to change direction or slow down would require careful planning. One wrong move, and you could find yourself slingshotting into the sun or out of the solar system entirely. Temperature is another factor. Comets are made mostly of ice and rock, with frozen gases like carbon dioxide and ammonia.
When they approach the sun, they heat up, releasing gas in a glowing coma and forming the iconic tail. Riding a comet toward the inner solar system would mean flying through this icy, outgassing cloud.
The heat and radiation from the sun could fry unprotected spacecraft or astronauts, so any passengers would need shielding, basically a tiny mobile space station built on top of a frozen chunk of rock.
Now, imagine the view. A comet's tail is not just one streak. It's a huge cloud of dust and gas extending millions of kilometers.
As you ride, you'd see the sun shining through these particles, scattering light into brilliant reds, blues, and greens. Nearby planets might pass by like glowing marbles, and meteor showers could appear as fireworks caused by tiny fragments shedding from the comet's surface.
Riding comets could also change the way we think about interplanetary travel. Currently, moving between planets requires enormous amounts of fuel to accelerate and decelerate. Comets are already moving at incredible speeds, often faster than any rocket we've built. In theory, if we could harness their trajectory, we could ride them like a natural, reusable spaceship, traveling from the outer solar system to Earth or Mars in record time.
But there are risks beyond gravity and heat. Comets can break apart unexpectedly. Many have fragile surfaces held together loosely by ice and dust.
A collision with even a small rock or an outburst of gas could shatter the comet, sending debris in every direction. Riding one would be like surfing on a frozen, exploding roller coaster, exhilarating but potentially deadly. Let's talk about control. We could theoretically attach thrusters or robotic stabilizers to steer a comet slightly, using jets of gas from sublimating ice. This would let us nudge it toward desired destinations. Even small adjustments could make the difference between a safe flyby and a catastrophic collision with a planet or moon. There's also the question of life support. Even if we had a way to hold on to the comet and control it, passengers would need oxygen, food, and protection from radiation. A comet could act as a mobile base, ice for water, rock for shielding, but we'd need highly efficient systems to make long-term travel feasible. Interestingly, comets could serve as natural laboratories for studying the origins of the solar system. They contain ancient ice, dust and organic molecules, pristine samples from the early solar system. Riding one could give humans direct access to materials that have been untouched for billions of years, offering insights into the building blocks of planets and life.
From a cosmic perspective, riding comets would blur the line between exploration and survival. It would be faster than conventional spacecraft, potentially cheaper, and certainly more exciting. But it would also push humans into extreme conditions, relying on technology and ingenuity to survive on a small, fragile, speeding body in the vacuum of space.
And let's not forget the spectacle. The sun rising and setting behind a comet's tail, planets in the distance, dust streaming past. This would be one of the most breathtaking experiences possible in the solar system. The thrill would be unlike anything on Earth, combining the raw beauty of space with the adrenaline of riding a natural spacecraft.
So, what if humans could ride comets like spaceships? We'd gain the ability to travel vast distances at incredible speeds, witness cosmic phenomena up close, and study the building blocks of our solar system firsthand. At the same time, we'd face extreme danger from gravity, heat, radiation, and the fragile nature of the comets themselves. It would be both the ultimate adventure and the ultimate risk, surfing on ice and rock across the cosmos. It's a reminder that space is full of opportunities and dangers in equal measure. And if humanity ever masters comet travel, it would redefine what it means to explore the solar system, turning frozen remnants of the past into the highways of the future.